Hi folks, this is a solution to number 17 on page 378. So they give us this relationship between A, B, and C that they all sum up to 0. They give us the magnitudes of the three vectors, and then they want us to determine this expression here. Okay, so here I notice that I'm given the magnitudes and I'm finding a whole bunch of dot products. So at some point I'm probably going to have to figure out the angles between the vectors. Okay, so let me start with that information that they give me, that since these vectors add up to 0, it means that if I add them tip to tail, they should form a closed triangle. Okay, so say this is vector A, okay, and I add vector B to it, and then I add vector C, and I should end up exactly where I started from. And this is magnitude 1, 2, 3. Now, if I just sort of went to solve this problem without thinking about it, say I might pick this angle here, theta, and, once I find this angle, I know that I can move the vector C in order to find the angle between A and C. So let's see what happens when I determine that angle. Okay, so let's do theta is going to be equal to cos inverse of, so its opposite side has magnitude 2, so 2 squared minus 1 squared minus 3 squared over negative 2 times 1 times 3. Okay, and let's figure what that's equal to. So inverse cosine of 4 minus 1 minus 9 divided by negative 2 times 1 times 3. And I get that that angle is equal to 0. Okay? Now, if you think about it, it's not too surprising, because if these two sides are 1 and 2, the only way the third side can be equal to the sum of those two is if I have them placed one after the other. So this would be, angle A, vector A, vector B, which is magnitude 1 and 2, and then this would be vector C. Okay, so in fact, they don't form a triangle, they just form this sort of line going back and forth. Okay, so it's actually going to make the question a lot easier. So here, if I, I'll use subscripts here. So if I want the angle between vectors A and B, well, they're in the same direction, so that angle is going to be equal to 0, but the angle between A and C and B and C, since they're just in opposite directions, is just going to be 180. So B and C, 180, and between A and C is equal to 180. Okay, so now I can go ahead and determine this expression. Okay, don't feel like rewriting it. So that's just equal to, well, magnitude of A times magnitude of B times cosine of the angle between them. So that's magnitude 1 times magnitude 2 times the angle between A and B we said was 0. Here we have magnitude of A, which is 1, magnitude of C, which is 3, and the angle between them, which we said opposite directions, so 180. And then plus magnitude of B is 2, magnitude of C is 3, and the cosine between them again is 180 degrees. Okay, this is just equal to 1, this is just equal to negative 1, this is just equal to negative 1. So what do we have? We have 2, here we have minus 3, and then here we have minus 6. Okay, and so our final answer, 2 minus 3, negative 1, minus 6, negative 7. Okay, so just to recap here, is the main thing was to use the fact that these three vectors added up to 0. Okay, now had they not formed this sort of line that goes forward and then backward, if I did have this closed triangle, it would just be a matter of finding the angles in the triangle to help me find the angles between the vectors, and I could have solved this with just a little more work. In this case here was a little easier because it turned out that the angles between the vectors were either 0 and 180. Okay, that's it for this one.